Good afternoon, everybody. My name is Lynn Loo. I lead the Global Center for Maritime Decarbonization by day, and I'm a professor in chemical engineering at Princeton University by night. It's a pleasure to be here talking about maritime decarbonization with you. I think Eric set the stage very nicely by giving you some very sobering statistics, right, on how hard decarbonization is. Those statistics are not meant to be crippling. They're there to ground the discussion. And it's really only by understanding how big that challenge is, can we figure out where we fit in and how we plug in and how we can contribute, okay? So I'll just start by saying that. And the other thing I would say is what I'd like to do is to tell you about the recent efforts at the Global Center for Maritime Decarbonization. We've only been around for about 14 months, so I'll tell you about the 3 big projects that we've started. And then I'd like to end on a more macro outlook type of a message to sort of look forward and see where we're headed. So shipping, you've heard, is a very difficult to abate sector. We've heard that over and over again, and Eric has mentioned this, James has mentioned this. Why is it difficult to abate? Well, shipping as a sector is quite heterogeneous. It's got 55,000 ships on the water with different segments. They ply different routes. The ships are different sizes, of different age. So it's a very heterogeneous segment. And what that means is you're going to need a very heterogeneous portfolio of solutions to think about decarbonizing the sector. The other is oil and gas is sticky. I mean, just look at the statistics from MAN engines, right? By 2030, 85% of these large 2-stroke engines are still going to be burning fossil fuels. By 2050, when we're talking about net zero, about 1/3 of these engines are still going to be burning fossil fuels. And this comes back to what Eric was saying, right? I mean, it's at the end of the day, you need green electrons. And green electrons, you need to build enough solar, build enough wind, and all that's going to take financing. It's going to take time. Yeah. The ecosystem for maritime decarbonization is not mature. We heard about energy efficiency measures. That's great. That can shave the emissions. That can help us bend the curve. It's not going to get us to net zero. At the end of the day, we need the alternative fuels to get us to net zero. So just another statistic to add to what Eric has shown you. Increasingly, we've talked about having to need 5% green fuels by 2030 if we want to completely decarbonize shipping by 2050. So what does this 5% translate to? 5% sounds very little, right? 5% sounds like it's doable. Well, the 5% translates to about 40 million tons of green ammonia or green methanol. The energy density difference between the two is only about 20%. So it's about 40 million tons by 2030. Again, to put that number into perspective, today we produce about 200 million tons of gray ammonia. Only 20 million tons are being shipped around. So we're going to use the 20 million tons, and that's only half of what's going to supply this 5%. Or you can look at the IRENA report that's just come out in May, and there they counted up all the green ammonia projects, and they projected forward, and by 2030, you'll have 15 million tons of green ammonia, right? Same story that Eric was saying. It's hard, it's challenging. But what that means is there are tremendous opportunities for us to think about how to move forward. Oh, sorry. So this is the fuel supply chain. At GCMD, how we're thinking about the fuel supply chain is we're trying to figure out where the gaps are, because by identifying the gaps, we can ready the sector to adopt these green fuels when the green fuels are ready. So the kinds of questions we're asking are, well, how do we ensure safe handling and use of green fuels? How do we implement, emissions accountability when you have green fuels and you have gray fuels, like green and gray ammonia? Chemically, they're the same things. How do you tell them apart? Because the green ones is going to command a premium over the gray ones. How do we work with other sectors, like the power sector, so that we can aggregate demand? And when we aggregate demand, we can bring green fuels in cheaper, faster, and sooner, right? How do we close the gap between the marginal cost between green and gray? So those are the kinds of questions I think the sector is positioned to try and answer before the green fuels are available, right? We can start to think about how we can plug in these gaps so that we have answers to these things before the green fuels are available. So the ecosystem is complex, and this is how we think about the ecosystem. I'm showing you here the fuel supply chain. So there's the fuel producers, there's a supplier, and then of course the vessels that then bring the fuels, whether it's the vessel at anchorage or vessels at berth that bring the fuels to the vessels. And then ultimately there are the cargo owners that also play in this ecosystem. So this ecosystem is tremendously complex. And earlier on, we heard about how collaboration and partnership is so important in thinking about decarbonization. These are all the players that need to come together in order for us to think about decarbonization holistically, right? It's not something that one company or one person can do alone. And so this is exactly how we look at the problem and we look at the challenge. So we're very fortunate to have lots of players in the ecosystem that have come along. These are some of our funders and partners, and you can see they span across the supply chain. And that's really important because they provide the perspective, they provide important experience that we can learn from. It helps us ask the right question so that we can scope the pilots appropriately. And I'm very, very excited to just give you a sneak peek that next week we're going to sign a partnership agreement with a Norwegian financial services company. So we're super, super excited about this because again, it provides and brings in a different perspective that can help us move along this decarbonization journey. So let me tell you a little bit about the 3 projects that we've embarked on. Again, I mentioned that we're about 14 months old. This is one of the first projects we started, and this is along the fuel supply chain. We readily acknowledge that green ammonia is not going to be available until probably mid-2030s. But that's not to say there aren't gaps within the sector that we should be thinking about. So when GCMD embarked on this project, we were looking where there are gaps. And one of the gaps that we identified is how do you safely bunker ammonia? Ammonia is super toxic. So wanting to use it as a fuel, we need to figure out how to do this safely. And so we commissioned a safety study, and this is being done by DNV in collaboration with Surbana Jurong and Singapore Maritime Academy to identify and outline the safety guidelines and the operational guidelines for bunkering ammonia safely. This report and this study is on track, so we are closing this out before the end of the year, and we would be ready for public sharing next year. What this study will do is it will generate safety guidelines down to the flow rates with which you're going to transfer ammonia as a fuel, down to the kinds of pipes you need. So these safety guidelines can then be pushed up to become technical references. We're looking to how this was done for LNG as an example, but LNG took 8 years to be done. We want to compress this timeline down so that these safety guidelines can become technical references much sooner. And then what we'd like to do then is to, sorry, this thing is very distracting because it keeps moving around. And then to use that to push it through standards development organization so that it can be part of the standards for bunkering ammonia safely. Alongside, what's important about the study is that we're going to generate these competency frameworks. Because not only is it important to have safety standards and safety technical references, it's important to train the seafarers and the bunkering operators on how to handle ammonia safely. So there's a competency framework piece that's associated with this study, and this is going to be translated into a curriculum. That's why Singapore Maritime Academy is involved, so that they can properly train the seafarers and the bunker operators on handling ammonia. Again, I would say that it's very important to have partners involved. And in this study, there are 22 study partners across the supply chain that are coming to provide their experience, to help us think about the study so that these guidelines become more robust. And throughout the talk, you'll see that these partnerships are so important because, like I said, we can't do this alone. So we talked a little bit about green fuels, and this is Lawrence's reference to bending the curve. So this is bending the curve. So not only is it important to think about green fuels, we've already acknowledged that green fuels aren't going to come anytime soon. It's important to do what we can with what we have now. So that means we need to think about near-term solutions, we've heard quite a bit about energy efficiency measures. Of course, those need to be adopted as quickly as possible. That's not where GCMD is focused on because there aren't technical gaps there. That's an adoption bottleneck. And so ship owners, ship charters should adopt these technologies as quickly as possible. Biofuels are available today. Liquefied natural gas is available today. Provided that they're sustainably sourced and responsibly used, they can help you shave emissions. That's something that we should think about for the near term. And then for the midterm, we think carbon capture is important. Carbon capture provides the runway for these green fuels to scale. And you heard James talk about how important carbon capture is to his company. So let me take you through two quick examples for near-term and midterm solutions. About 6 months ago, we announced a biofuels pilot. This is a drop-in fuels pilot that involves 13 vessels bunkering at 3 different ports in Singapore, Rotterdam, and Houston. Now, biofuels pilots have been done quite a bit, and most of them have demonstrated that you can burn biofuels on board ships. Here, the goal is to bolster the integrity of the supply chain, is to provide an assurance on the quality, and the abatement potential of the biofuels, because these biofuels are going to be blended with standard fossil fuels. Knowing how much there is, knowing what it is, where it's from, and knowing what the carbon factor or the carbon intensity is gravely important if you're going to think about reducing carbon intensity. So we're going to put a tracer in the biofuel at the source and then follow it down the supply chain so that you know exactly where it comes from. You heard palm oil is very bad, so we don't want that. So you know the origin of the biofuels, and then we would be able to trace emissions that way. This framework is important because beyond biofuels, when bio-LNG is available or when biomethanol is available at cost and you're blending this with LNG, it's important to know what is green and what's not green because that can justify the marginal cost that you'd be paying for these fuels. Okay, so again, an ecosystem of partners. The 13 vessels from 13 companies of fuel purchasers. BCG is helping us on the impact assessment side of things. Bunker Trace is the tracer solution provider. We're not married to this specific tracer solution, but the point is we need to start somewhere, and we picked Bunker Trace as the one to work with. And then Men Engines is on here as well. The important thing is these partners, they represent across all segments, and you can see sort of the tonnage that they represent, which is so important because I think that means the learnings that we get can be pushed out. Here I'd like to talk about shipboard carbon capture. So shipboard carbon capture is doing carbon capturing on ships. So as long as we're gonna do accounting of emissions by sector, we need to think about a way to remove carbon dioxide within the sector, right? This is not the most efficient way of doing things, but that's the way accounting works right now. From a carbon capture perspective, there is the capturing that one needs to worry about, but then you need to liquefy the CO2, you need to store the CO2 on board, and then you have to worry about offloading the CO2 and who the off-taker is. That's really sort of the value chain of capturing CO2, right? So you can't just think about the capture piece, because even if you've demonstrated the capture piece, if you have no means of transferring it and then utilizing it or sequestering it at the end of the day, if you're releasing it back into the air, then you've done the atmosphere or the environment no good. So we embarked on this carbon capture project. We just launched this last month. It's called Project Remarkable. It's going to be the world's first end-to-end demonstration of shipboard carbon capture at scale. So these are some of the stats that are on here. The pilot's going to be carried out on Stena Impero or one of its sister ships. In fact, I actually boarded, this is my photo. I boarded the ship to see where the CO2 tanks are going to be because we need 2 300 cubic meter CO2 tanks to store the CO2. For every ton of fuel you burn, you generate 3 tons of carbon dioxide. So you generate a lot of carbon dioxide, and space on these vessels are a commodity. So it's important to figure out where it goes. It's important to figure out the energy balance because these scrubbers are very, very energy intensive. So the last thing you want is to actually have to use way more energy than you need to in order to capture carbon. And then, of course, it's the offloading piece, and then who the off-taker is. So we've identified an off-taker that will take the CO2 and use that CO2 that is generated. Now, we've chosen an MR tanker because similar sized vessels emit 17% of shipping's emissions, right? So if we can demonstrate this end to end, and if it's feasible end to end, it can go a long ways to helping the sector decarbonize, because this solution would be applicable to similar sized vessels. So again, you'll see that there are partners involved because partners bring different strength, and this is the only way we can take a systems approach to doing these kinds of pilots. So I'll end on a macro note. I think it's fascinating. We're in very exciting times. I mean, I'm very new to shipping. I'm only in shipping for like 14 months. But just looking ahead, I think there are lots to think about beyond just decarbonizing the sector, right? I think there are going to be alternative business and operation models because we're moving from an energy dense fuel to something that's 2.5 times less dense. Ships, as I learned, they generally, more than 50% of ships bunker at one hub. No matter where they go, they come back to one port. But that model probably is going to change if your energy density is going to go down by 2.5 times. You either have to think about bunkering more frequently, or you have to think about having bigger tanks on vessel. How is that going to affect the business model of shipping? When we think about green fuels, there's going to be massive, massive build out on the land side, and there's going to be a need for new supply chains. Where does shipping play in that? And then finally, there are new roles and business opportunities. We talked about capturing carbon. If you capture carbon on land side, it's clear that where you emit carbon dioxide and where you can store carbon dioxide, so sources and sinks, are not going to be in the same places. Does shipping play a role? Is there a big role for shipping for the captured carbon dioxide? And then ammonia. Right now we're producing 200 million tons a year. It's going to go to 300 million tons by 2030. This is going to have to be shipped around because it's going to be an energy source beyond just for green marine fuels, right? So I think there are tremendous opportunities, and we should think more broadly the implications of decarbonization on shipping's operations and business model. So with that, I'll end here. Thank you.